Okay. What a stupid place for that projector. Like, honestly, I can't stand at the desk without getting blinded. Okay, data normalization. Essentially it's a tool to validate and improve logical design. It's a process. Essentially, you are going to take relations and break them down to the smallest possible piece. Now, to be completely honest, that's not something you see very much anymore. Having to go through the process of normalization. Why? Because A, very few new databases are being created from existing non-database sources. Right? There used to be days where companies, everything ran on paper. There's paper invoices, paper everywhere. The old System 36 database servers could not cope with certain table structures. Even the first AS400s couldn't cope with it properly. Data structures suck. Now that the relational model was created, pretty much any database that was designed against a relational database server tends to be at least mostly normalized. I can guarantee, let's say there isn't 100 people in this room, let's pretend there's 100 people in this room. Out of the 100, 3 of you may need to normalize a database within the first 2 years of working. But why is it important? The concept of normalization applies to other disciplines other than database. It allows you to break things down. All right.
So is it similar to like converting to digital?
It's sort of like taking, I'll be putting examples up, I'll be going on the board and I'll do an example on the board. I want to get through this fairly quickly because I can cover some of the stuff that's supposed to be in assignment 1. The joins. So I got to cover that. So, a well-structured relation, minimal data redundancy. In other words, you don't repeat data unless you have to. For example, having a list of countries or provinces. If it's a properly normalized database, you'll have the countries in its own table with just a foreign key so that you're not constantly retyping in each of the country names. This is where I'll use an anecdote. When I first started working where I am now, we're talking 16 years ago, they had a web form where customers could register. And the country field was a free text field. And then one day they asked me, Dan, can you run a report of all our customers in the US that registered? Sure. That's when I discovered people are stupid. I already knew that by then. Right, because you always have to assume your end users are idiots, but I discovered they're even dumber than I thought.
America, USA,
oh, we had
States.
USA, United States, U.S., U.S.A, U.S.S. You know, various United States of America, just United States, various and sundry versions of that. And I had to find every possible combination of that to find the entire list. Thus, there's data repetition, data corruption. A well-normalized database doesn't allow things like that to happen. There's anomalies. An insertion anomaly means when you add a row of data, you are forced to create duplicate data. There's examples. Next slide. Next couple of slides. Deletion. If you delete a row of data, you're losing other data that shouldn't be lost. In other words, you delete a row, you lose everything. Modification, in other words, you have an end user whose name, let's say you're talking about dentists, and you had a female dentist, you heard she got married, and she changed her last name. In a badly normalized database, you have to update every single row where her last name appears. As opposed to, if we had a dentist table, you change it in one place. So as a rule of thumb at the bottom, the nice big red text here, a table / an entity should not pertain to anything more than a single kind of entity. In other words, if you have a table for students, and you should be using the students table to also hold the teachers. You should have a teacher's table and a student's table, unless you're going to do something a little different with your table structure. But as a rule of thumb, that's actually not a really good example, but I'm going to go with it. So you got teachers and students. you shouldn't have them in the same table with their full descriptions. Because can you imagine you hired a teacher and the only way you could put that teacher is if you had a student? Or you're a student and you register into the system and you can't be registered unless there's a teacher assigned to you already? That's a no-no. Okay. Here's an example of a table that is sort of first normal form, essentially, what they call, there's many normal forms. This is first, sort of. But essentially what we have in here, we have multiple copies of each one, right? We can identify them uniquely. The employee, there's the name, there's the department, her salary, the course she took, and when she took it. This is a compound setup where you have to use the employee ID and the course title to identify a specific thing. But let's just say we were going to go and nuke Alan Beaton. Okay, Alan Beaton got walked out the door today. We suddenly we lose the fact that the accounting department existed. We also lose the fact that they took the tax accounting course. Thus, that's a deletion anomaly. It's very bad. The whole point of using a database server is to not lose data. But if you do something like this, you know, we take Alan out back and, you know, dispose of him. We also dispose of the fact the accounting department existed and that he took tax accounting. Usually it's this where I make a joke about accountants. You can just imagine. Okay, so actually we pretty much covered some of that, right? There's the deletion, the modification. If you give a raise to one employee 100, you have to update multiple records to reflect the fact that they got a raise. And back in the old way computer systems used to work, you used to have to update the rows one by one. You couldn't do a batch. Now you can, but back then you couldn't. If you wanted to update employee number 100, find record number 1, update. Step to the next one, update. Step to the next one, update. Then the computer shits the bed. And now the next 100 does not have the raise, so suddenly employee 100 has to give them salaries. How much is employee 100 actually supposed to get? We're going to give them the lowest salary because we don't want to pay them too much. Maybe you got a demotion, not a promotion. There's no proof. All right, why does this happen? Because there's two kinds of entities in the same table. All right, so here's the steps of normalization. So for the first normal form, you get rid of multi-valued attributes. So in other words, attributes that can have multiple values in it, get rid of those. Then, to go to second normal form, you get rid of partial dependencies. In other words, do some of the fields. So you got a table where you've got two primary keys, but there's a couple of fields that only depend on one of the two primary keys. That's a partial dependency. Take those, put them somewhere else. You're now in second normal form. Third normal form, they have what they call transitive dependencies. I'll cover those in a few slides. That's third normal form. Then you get rid of the anomalies because of multiple candidate keys, and then you're in voice cod. In other words, if there's not more than one thing you can use as a primary key, you're now in voice cod. For example, students is actually a really good example to use for that. Because you have a SIN number, you have a student number, you might have a student visa number depending on where you come from, or a passport number. You have different ways of being identified in the system uniquely, but the problem is that SIN number applies to you. If you're from somewhere else, I don't know, I'm not going to point at anybody because I really honestly don't know. You might have a student visa number or a passport number instead, and the system will uniquely identify you because you don't have a Canadian SIN number. Therefore, there's possible multiple candidate keys, and how do you know which one's the right one? You don't, therefore you create a new key, a super key, an ID field. That makes all the other candidate keys null and void because you can use them as just regular attributes at this point. Believe it or not, I just explained the whole concept of normalization in 3 seconds. But we're going to go through it a little bit more. Functional dependencies and keys. You need this for MyLab 5. That's why I'm going through this. Now, functional dependency. The value of one attribute determines the value of another attribute. Okay. That sounds kind of stupid, the way they worded that. But essentially, you have one attribute, and then you have another attribute. And this attribute can't be defined unless you have this one first. And it's not a case of it's, you know, SIN number 1, 2, 3, 4, 5, 6, 7, 8, date of birth, March 7th, 75. it's a case of you can't have March 775 unless you got that SIN number.
SIN number, yeah.
Okay? That's a functional dependency. In other words, that date of birth is functionally dependent on the SIN number. A candidate key. It's a thing that could be used as a unique identifier. In other words, anything that is non-key should be functionally dependent on every candidate key. In other words, if you've got a table that has 2 candidate keys, therefore, every field that's not a candidate key should be dependent on
Those 2.
all of those candidate keys, not on just one of them. Otherwise, it's a partial dependency. And if it's a partial, break it out to another place.
Functional dependencies will always relate to primary keys.
Well, by the time you're done. When you're starting, no, but by the time you're done, yes. Okay, first normal form. No multi-valued attributes. In other words, a multi-valued attributes example. What are your skills? Okay, FileMaker is a skill. Sort of. It's like Access for Mac, but dumbed down. You could have PHPs, Java, C#. Those are, let's say you define yourself, these are my skills, and you have that as a single field. That's a multi-valued attribute. That's no good. That should be in a separate table. In other words, if you have like a list of common delimited values in a single field, don't do that. It's horrible. Every attribute is atomic. In other words, every attribute is self-contained onto itself. Your date of birth is an atomic value. It's not compound something else. It's your date of birth, self-contained atomic. Yes?
For something like skills where you actually need the user to input something, how would you store that?
You'd have it as a child table of user. You'd have user skills. That way the user can have n number of skills. Any given skill belongs to one user. Okay. All right, here's our figure 425. This is not first normal form. Can somebody take a guess why? It's also not a proper relation. Yes, you got multiple line items without anything on this side. Therefore, there's not complete rows of data. Just the way this is defined, it's not in first normal form. There's no, you can't, like if I go look for product ID number 5, I can't even tell who ordered it because the data is not there. That's not even a proper entity. If you're going to make it first normal form, so let's flick back and forth for a second. Back and forth. Back and forth. I did it enough times now. You can see what was changing. It's a terrible design table. But at least I can find everything order ID 106 has in it, or I could find any given order that product 4 is in. I can find this. Basically, our primary key would be order ID and product ID. But this is where we get some of that weird functional dependency bit. Right? The order date is functionally dependent on the order ID. We've got the customer ID, which is also apparently part of the order ID. And the customer name, and as you notice, this is actually related to this. This will be going away soon, its own place. But it has a lot of duplication. So, for example, here's an anomaly. We delete order 1006. What happens?
You lose both.
We lose both of these and?
You lose those product IDs.
Yeah, you're going to lose dining table and the writer's desk. And the camera doesn't see it all what I'm doing here, but at least they can hear my voice.
Why not all 3?
106, yeah, you're down here. But number 4 is also in order 107. Therefore, we're not going to lose item number 4 because it's already somewhere else. We'd lose this instance of it. But if we were to nuke, same thing here, we nuke order 1007, we lose product ID 11, but we get to keep 4 because, well, 4 won't exist here, but it still exists up here. Okay, there's the anomalies. I just finished talking about them. Go figure. Okay, second normal form. It's in first normal form, and every non-key attribute is fully functional, dependent on the entire primary key. Okay, so in other words, every non-key attribute must be completely defined by the primary key. And there's no partial dependencies. So in other words, part of the only part of the data is dependent on the primary key. Get rid of that. And we got another little diagram. This one's fantastic. Okay. The record, the full dependency of the record, order ID, product ID. But if you got the description, the product finish, and the product standard price is a partial dependency of product ID, because really that's actually part of the product, not of the whole order. Same thing here. On the order ID, we've got the order date, the customer, and the customer information on the order. So that's a partial dependency of order ID. So this here, we could split in half. And when we look at what's down here, we got the order ID gives us the order date, customer ID, blah, blah, blah. Customer ID has has what they call a transitive dependency. In other words, it depends on the order, but it's transitional. In other words, it's actually parts that are dependent on something else. The product ID has the product description, and then the order has the order ID, the product ID, and the quantity that they ordered. So order ID, product ID, and quantity is actually the order line.
What else is customer ID dependent on, apart from order ID?
The customer the way it's currently designed, the customer ID is dependent on the order ID. For now.
Okay, but you say it's transitive because
It's transitive because
eventually it will
it's
become.
It's being removed. Oops. So, second normal form will look something like this. You got the order ID with the quantity and the product. You have the product ID, the description, all that fun stuff. And then you've got the rest of the stuff, including the transitive dependency of the customer. The partial dependencies are removed, but there's still a transitive dependency. So that means now it's in second normal form because there's now no more partial dependencies for now.
So here, the transitive dependency, customer ID depends on customer name, customer address, as well as order ID.
Well, the way it's currently designed, customer ID was not part of the primary key. Therefore, it's a transitive because there's a few pieces of information that depend on it, and this one depends on this one. So that's why it's transitive, right? This one exists because this exists, but there's some fields in here that only exist if that exists. So it's sort of like this chocolate child. Or if you want a really graphic image, someone's pregnant and the baby's pregnant. There's a bad graphic image. But that's essentially what this is right now, right? We've got a baby and the baby's got a baby. I use horrible examples like that because it really burns it home, right? No, really, you'll think about partial transitive dependency. Oh God, it's the baby thing again. But you'll never forget it. Okay. So third normal form, guess what? You can't be in third normal form unless you're already in second normal form. These build up on each other. In other words, there are no transitive dependencies. That's what third normal form is. It's basically second normal form plus one more rule. There's no transitives. And then essentially anything that's a non-key determinant, in other words, what they call the determinant is the customer number, is a determinant because the customer name depends on the customer number, but it's not part of the primary key. Therefore, it's a non-key determinant. If it's a non-key determinant, break it out, put it somewhere else. And we end up with something that looks like this. Bottom right corner, by the way, these slideshows are all on Blackboard. You can see now that the customer ID has been broken out. The customer has been broken to its own table. That means now that we can change the customer's name without altering multiple rows in the order. The order is a nice, clean environment, so the order has the order number and the customer number. All the information on the customer is only dependent on it to itself. That means that the baby's out of the baby.
Here is customer ID a foreign key?
Customer ID becomes a foreign key. So we have a customer, which has a name and an address, places an order, right? Another customer can have many orders. The order has an order date. You can see right here, here's the foreign key, customer. The order includes or has many order lines. So in here we've got the order ID and the quantity, right? So this order has many order lines. And the product has these pieces and it can be ordered as part of the order line. This is third normal form. It's not Boyce Codd yet. And the slides that go to Boyce Codd don't use this example because the textbook decided to stop using that as the example. This, to make this Boyce Codd, we'd add a primary key on this, a standalone primary key called, I don't know, ID.
ID. Yeah.
Well, I'd call it ID. But that's the order ID here. If you had a primary key, a non-compound key gets you voice cod, which is the next one.
So essentially, that's the only thing. Well, there would be other cases, but in this case, that's the
That
only
was
thing
it.
you'd have to do.
Yeah, that's all you have. Let's get voice cod. Okay, voice cod has issue. It's when you have a situation where you have issues like there's more than one candidate key, such as an order with two separate foreign compound keys, and relations in voice cod. If and only if every determinant in the relation is a candidate key. In other words, if there's anything in there that's a determinant, such as customer ID, if all the other fields depend on customer ID, then you're in voice cod. Before, for example, the order line, you have the product ID and the order ID, and you have the quantity. But let's say you threw in one more attribute of some sort that could be not related in one of those two fields. Therefore, that table now has an anomaly, but you don't have anywhere else to put that field, so you create a key, and you use that as your primary key so that those two are no longer a candidate key. You actually take out the candidacy away from them and you give it to someone else. Sort of like taking Trump, getting rid of him, and giving it to somebody else. Right? Because, he's not a good candidate. You know how long I've been waiting for that kind of material? It's the first year I've ever been able to use something like that as an example. But essentially, when it comes down to it, voice cod has a very simple way of describing itself that doesn't use any of these big fancy words. A table/relation is in voice cod when every attribute/field depends on the key and nothing but the key. In other words, there's no fields in that table that depend on something else. End of story. That's voice cod. I've got a bunch of slides after that talk about putting in voice cod.
But if you have a foreign key, wouldn't it naturally be dependent on something else?
Well, no, that's fine because it's a foreign key. But that foreign key only has one value in that table. There's nothing else depending on that foreign key in that table. Right? Sort of like if you had. Gotta be careful because this one's tricky. Let's say you have a product and you have a field called discount on the product, and then your order line also has a discount field. And that discount field can only ever be set to whatever the foreign key says it is. That is not in voice cod. At that point, the discount should either always be taken from the foreign key or removed from the foreign key and always applied only at the order line. You shouldn't be able to have a field that depends on this sometimes. If it can depend, if you can use the word, is this connected to this, and you use the word sometimes, you've got there's problems. You're not in voice cod. Now, as a rule of thumb, the accepted minimum level is third normal form. So if anybody asks you what's the standard database form, third. Voice cod is also known as 3.5. Because there's a fourth normal form, there's a third, there's a fourth. But somewhere along the way, they snuck one in the middle called BCNF. So it's known as normal form 3.5. It's basically third normal form plus one extra rule to get rid of those weird anomalies. That's its purpose in life, is to avoid weird.
Fourth form is rid of all anomalies?
It gets rid of a different kind of anomaly. Fourth normal form is taught like second level database course. Realistically, I don't think I've ever had to make anything go to a fourth normal form in 20 years.
Okay.
Fifth, sixth, and seventh normal forms, and there's another one past that, are only used in pocket protector land, also known as academia. They're normal forms used basically in university to prove that they justified the professorship and created a new normal form. Because if you get the voice cod, there's so little left that can go wrong that it's almost never. If something can go wrong, it's probably because of bad programming, not bad database design. Okay. Where did that go?
think that's the last slide we have on Blackboard.
It is, because I threw on a new one just for you guys. Because I combined parts of weeks 5 and 6 for you guys, so you can actually get some of the stuff you need for, so you guys are actually the problem is I'm going to fly through some of these slides pretty fast, because you've learned some of this already in the lab. Because my guys have not learned a line of SQL yet. They just finished all the theory. What I just condensed to in about 2.5 hours, 3 hours, they've gotten in 3 weeks with lots more examples and stuff. It's also been a little bit more refined for you guys because I've been through it once already this week, so I got my examples much more fine-tuned, and I've had questions asked, and I adjusted the delivery. So you guys have already had some SQL, so I'll be able to skip through some of this, and I'm just going to go through the first part of it fairly quickly. Then when I get a chance tomorrow, I'll upload this stuff. Okay, I'm just going to skip that. Okay, the select statement. What's the select statement used for, guys? I hope by now you know what it is, because apparently you've been learning it. You use it to retrieve records from the database. It's really, really flexible. You may not be aware of this, but it is very flexible. It's made up of 2, 3, 4, 5, and then it's at least 6 parts, depending on how you decide to write a piece of SQL. A lot of people don't realize that the select statement is made up of many pieces, because most people think of 2 or 3. Right? Select star from users. That's 2 pieces, right? The selection list and the target, the source list. Then you got the where clause. And then you could have an ordering, or you could have aggregate functions, which include now grouping. There's also a having clause and a limit clause, right? So there's lots of pieces you can use. For 90% of what you guys need to use, you pretty much stop after the where. All right. Okay, the field list, I think you guys should know what that is. Select star from, select asterisk, and just grab everything. Otherwise, you can use a standardized list of fields. Select ID, comma name. Let's say you've got a table with 100 fields in it. You only need 3. Did they explain to you why you'd want to use a set list of fields coming back instead of retrieving all of it? Did they actually ever explain to you why you don't want to do that? Okay, here we go. Anybody want to take a guess? Yes?
Well, all you need is that type of data. You don't need more.
Yes, but sure, yeah. That's why you'd want to do it. But there's a reason why you should do it. The should is most in network environments, server farms, will have the database server separate from the application server. Okay? Now,
Oh, it's big.
size. So let's just say, in actual fact, I have a database on a hard drive somewhere at home. That has millions of rows of data in it. One of the companies I worked for at one point, our customer was a company called Trialto. They were a wine distributor. They partner up with all the different wineries around the world to import wine into Canada and sell it into the various markets. And we wrote systems for them to automatically connect to each of the provincial liquor agencies and retrieve the sales for that time period and add them to a standardized database, so we can take all the weird formats from Quebec and the really stupid format from Alberta and Ontario's impossible to use format, so that then the guys at Trialto could run a standardized report of all that data. The sales table list, last time I saw it was 72 million rows of data. How many columns? 55 columns. 55 fields. So if you did, let's say you got the database server sitting over here, and it's the database sitting at 16 gigabytes of data, and you've got the application, the web server sitting over here that's about to serve it to the clientele. And the website's only supposed to show the name of the wine and how many bottles were sold, not to say that, the name of the wine and say the locations you can buy it at. If you did a select star from wines, go.
Crash.
And then you get PHP, which is what the web server side was written in, to parse that data. Instead of moving, let's say each row of data is 5K. 5K times 15 million. Right? Pretty gross. Well, let's say you just wanted to move just the ID, the name, and I don't know, that's the liquor agency. You just want to retrieve those 3 pieces of information. Maybe the data coming back would be
It's still
maybe
350.
500 bytes.
No, but you have what, 15 million rows, 3
Yeah.
columns. So instead of taking 5 columns.
50
No, you said
columns.
50. Oh, sorry. Okay.
Right, so let's say a full row is 150K, as opposed to 500 bytes. Right? That's why you want to do this as much as you can. A, your server will thank you. B, your network administrator will thank you. C, imagine your web server is self-hosted, but your data services are on Amazon. And Amazon charges for data coming out of their system, not what's going in, but they charge you for every byte coming out. And you're running one of these queries and it's pulling back a gigabyte of data every time you run a query. How big do you think your Amazon bill is going to be at the end of the month? And let's say that query runs once every 10 minutes.
Ouch.
Yeah. Do this. This is okay when you're trying to figure out what's in the table. Once you know what's in the table, go this way. Okay. Table list. There's 3 kinds. There's the single tables. And actually, it's just covered this week, but it's actually going to be covered, like, all of it this week, not just part of it. Well, some of it anyways. A single table. Select star from users. Bang, that's a single table. You got joins, which I say cover 2 lectures from now. No, I'm lying. It's going to be covered a lot sooner than that. Joins. In other words, you take data from table 1, but you need stuff from table 2. You're going to join to connect them. Derived tables. Again, 2 lectures from now. No, I'm not covering that today. Did he talk to you guys about subqueries at all? No?
It was mentioned somewhere, but
Okay, good. Mentioned, yes. I don't think it's not on the assignment. You're safe. Okay? And at the bottom, I got the example from test. By single table. Derived is an interesting concept. Okay, the conditionals. That's your where clause. Obviously, it's a series of Boolean expressions. You guys know what Boolean expressions are?
true, false.
True, false. Whatever you evaluate should be true or false. There's lots of operators. Like by now, you should know what your operators are: greater than, less than,
Equal to.
not equal to. But there used to be one that if you ever look at old code, now you guys are used to this, right? Not equal, because that's what it's up. That became standard in SQL about 6 years ago. What did we have before this? We called it the diamond operator.
Yeah.
Something cannot be greater than and less than at the same time. It's impossible. So in other words, you could say name's not equal to Dan. Because it can't be greater than Dan, less than Dan. Because Dan is all there is to it. You can have multiple clauses. By now, I think you probably learned about and or. And XOR. I don't almost nobody ever uses XOR, but it exists. And brackets.
XOR?
Yeah. Exclusive or. It's math. It's like you take this and you kind of multiply an OR result. I never really understood how it works. I never use it if I can help it. I've used it twice actually in the last 20 years. So. And it was for a very select thing and I had somebody explain to me what the hell I was trying to achieve with it.
We'll deal with that when we get to hardware.
Hey?
We'll deal with that in hardware.
Yeah, exactly.
Yeah, we learned it in Essentials.
Yeah, you should learn about it in Essentials, some of it. All right, and then brackets, right? Things inside of the brackets are evaluated first, and then he takes the results of that and applies it to everything else. In other words, I could say name not equal to Dan, or name not equal to Dave, bracket, and some other clause. What it'll do is it'll resolve this first, and then apply it against the next one.
Oh, so that's going to give you a table.
Yeah, well, you
and
guys
then
remember
look at that.
Bedmas in high school math?
Yeah.
Right? Everything in the brackets first, and you take the innermost bracket, resolve it, go to the outermost bracket, resolve it, and keep breaking out and out and out until you don't have any brackets anymore. SQL works the same way. So I don't know if they even talked to you about brackets in your where clause, but that's how it works. It's not really rocket science. You try it and it works. If it doesn't work, your probably brackets are wrong. Well, there's our happy operators. I guess I apparently covered that already. All right, there's a few special comparisons. There's in. Did you guys learn about in?
Yeah.
Yeah. All right, so in a list. Common limited values. Did you guys learn about between?
Yes.
Okay, good. Man, that's going fast. Is null or is not null? Or is true? In other words, it's a case where equal doesn't really apply. Something can't be equal to true. Either it's true or it's not.
Are true and null interchangeable?
No. True is true, false is false, null does not is defined but does not exist. Right? Take a box, it hasn't been opened yet. The inside is null because it's a vacuum. It's a really hard concept to explain. But imagine you magically created a box that has nothing inside of it. No air, nothing. The space has been defined. It can hold something, but nothing is in it. The second you open it up, there's air in it. It's no longer null. It's empty. But it's
not null.
But it's not null.
Vacuum?
Well, essentially it's vacuum. It's data vacuum. That's the closest I can explain to null. Null is a weird concept. Especially with Booleans, because everybody else says yes and no, right? With Booleans in database, you have yes, no, and well, we don't know, which is the null. A null Boolean is unknown, and we don't know if it's true or not yet. Schrodinger's cat, is it alive or not? We don't know until we open the box. Then you discover the cat's an asshole. You laugh, I have cats, that's where I get to make the cat jokes. Not modifies those other operators. You can say not in a list. In other words, you're trying to get a list of data and it's IDs 1, 2, and 4, but you want everything else that is not 1, 2, and 4. Same thing with not between. So in other words, anything that's not between 1 and 4 will give you everything 5 and up, 0. Or is not null. Give me anything that has a defined value, whether it's an empty box, but not a vacuum-filled box. So as long as the box has been defined and an empty string has been put in the box, that means it's not null anymore.
Do you use null anywhere? Is it
All the time.
Yeah.
All the time. Nulls are great because it gives you the ability to define something without actually giving it a value. So every once in a while you'll create a record in the database and you don't know what that value, the end value is going to be for a field. That's why that's why it's null, right? Instead of being not null, it's nullable.
No.
Trying to come off the top of my head an example, an email address, right? You can define it as somebody, when you start some websites now, you sign up, it asks you for a username and a password, and once it's accepted that, it brings you to the next page where then you can put in your name and your email address. Well, up to that point, it's created a record with that username and that password, but the email address is still set to null. So that it just so happens that all you had time is put in your username and your password, and you've authenticated, but you haven't time to go through the rest of the profile update. At least the data exists and it's attached to you now. Your username is now safe because it's registered, but the rest of it hasn't been defined yet. That's nulls.
Everything in your bracket, are those rows or columns? The 1 to 6?
Those are values, possible values.
Okay.
Right, where ID is not in this list. So
so
ID 1,
okay,
ID
okay.
2, ID 4, ID 5. So let's just say we had a table with 6 rows of data, IDs 1 through 6. And I said, give me everything that's not in 1, 2, 4, 5, and 6, and give me one row 3. Right? If you notice, 3 is not in that list. Okay, pattern matching. You guys learn about like?
Yeah.
Sort of.
Well,
Quickly? It's mentioned on the way by.
Yes.
It was a drive-by liking.
Access.
In Access, so okay. Yeah, Access doesn't do like other databases. Okay. Basic matching uses the like operator. By the way, Postgres is case sensitive. I'm sure John tripped over that a couple of times. He sent on a hate mail to all the other teachers about how retentive Postgres was about case sensitivity. Yeah.
He actually didn't talk about Postgres.
he didn't remember the word
He was
Postgres.
teaching us Access the entire time.
whatever. It's okay. Don't feel bad. A lot of the concepts still apply. Okay, anyways, Postgres, as you may have noticed in your labs, maybe, is anal retentive about case sensitivity. Very, very much so. Just to be honest, there was this flaming email batch that happened after somebody discovered that Postgres was case sensitive and started writing about how it's not standard. Congratulations, there is no standard. The SQL language itself, like the select, where, from, that is not case sensitive.
Oh, it isn't?
That's, the keyword is not case sensitive. Object identifiers are case sensitive in Postgres, in Sybase, in DB2 most of the time, in MySQL depending how they installed it, and it's never case sensitive in Oracle because Oracle's stupid. For example, as you've probably discovered by now, when you're programming and you define a variable, this and that are two different variables, right? Postgres is the same way. Postgres is created on Unix, which is now, it's still Unix, but Linux basically inherited the concepts of Unix. And Linux is case sensitive, very, very much so. So therefore, Postgres is case sensitive. So Postgres offers one extra operator called ILIKE, insensitive like. So if you need to do pattern matching and you don't want to worry about the case sensitivity, you use ILIKE.
Okay.
There's a slight performance hit. Tiny, like microseconds.
I like it.
Yeah, exactly. I like it. Nice try. It's a good sign. Camera recorded that. Okay, so there's two wildcard characters that are defined by standard in the SQL language. The %, which is match any character any number of times, and then there's underscore, match any character at least once. I'll be going through some of this again later, so don't worry if you don't get it quite today. For example, ABC is like ABC. Of course, it's going to be true because it's an exact match. ABC is like a %, that's also going to be true. If I go ABC like %, a %, is also going to be true because A is somewhere in the string, whether it's at the beginning or at the end or the middle. Here's the other one here. Underscore B underscore is true because B is in the middle. However, if I go with ABC like C, is going to be false because it's not an exact match. Also, by the same token, if I said, if I were to compare a field value that was ABC, just like that, and I went like C %, that's going to be false because it doesn't start with C.
Also, percent is like a blank after.
C could be anywhere. %sign is a wildcard. It means it'll match any character any number of times. And by any number of times, it means 0 or more times. Underscore means it will match that
Last.
once. It'll match anything and it has to be there at least once. In other words, ABC like this will be false.
But C
Because-
is there once.
No, but one character. This would have to be A, C, or B, C.
Okay. So if you use underscore twice over there, it would match?
Then it would match that because then you'd have
Yeah.
two spaces. Yes?
Rather than use two underscores.
Sorry, does underscore A, would that return A or would it fail?
It would fail
It would fail, okay.
because that assumes there's something in front of A.
Okay, so it can't be null with 0. Okay.
Yeah. So the underscore means there must be something there.
To make it return true, would it be underscore underscore C or?
You'd go, in this case, underscore underscore C. That means you're trying to find C with two things in front of it at all
Okay.
times. Okay? So I'm going to skip the next slide because I want to save something to teach later. Group conditionals, I explained the brackets already, which is, I already covered that, but I'll cover more details. skip that. Distinct, you guys know about distinct?
Yes.
It returns unique rows. That means if you had a row that had the same email, let's say you had a table where people register, but you don't check whether or not something is unique, like an email address. So you have a contact form on your website, and you don't care how many times somebody fills out the contact form because it's a new request for information. But let's say for somebody at the end of the month, a marketing guy wants to send out a mailer to everybody who's registered once in the last month for a comment. Then you can do a select distinct email and give you one copy of each unique email address. Yeah, so that's what distinct is for.
So taking away
What's the
repeated.
difference between distinct and group by?
Group by is used for an aggregate.
Yeah.
I don't know if I'm covering aggregates today. Did you guys have to use aggregates in that assignment 1?
Yeah.
Yeah? No?
Wait, no, it's not 5%.
Applicants and
Okay, so if it's not in assignment 1, I'm not talking about it today. I'm just going to get to the point where we're talking about joins. Ordering, you guys learned about order by? So, okay, good. Okay, I'm skipping that. Did you learn about aliases?
Yes.
Giving temporary names to objects? Okay.
Distinct is to remove repeated fields. Is that what I?
It is to remove the repeated sets of fields. Let's explain that a little better. Okay, so I've got 2 rows, similar data. And let's say I want to say return both of those. And I say distinct. Okay, now you gotta look at this whole row. DanG@gmail.com and Bob. This one is Dan@gmail.com and Frank. As a set, they're distinct from each other, correct?
Yep.
Well, let's just say we just want to return the email address. Suddenly we go, I just want Dan@gmail, therefore the distinct value is it would only return 1. Whereas the previous example it would return 2. That's distinct. By the way, if you do a distinct select star, it's useless. There's no point doing a select distinct star because you're returning every column anyways. It's going to be distinct. No matter what.
But you can have the same column twice, and that it's going to return to you as.
Yeah, but you're going to be returning the primary key every time. The primary key should be
Primary
unique
key.
every time.
distinct will be a result one result.
Distinct would be one. Well, necessarily. Let's say you got a million. Let's say you got a table with 10,000 rows, and there's email addresses in it, and there is the same email address appears in it 25 times. It would only be returned once with the distinct. So that means you get 5,000 rows, and you might have 1,000 distinct email addresses in it. So if you decide to select distinct email from whatever table, you get 1,000 back, not 5,000. Okay. All right. Yeah, here's the joins. Yay. This is what you need for assignment 1, apparently, I've been told. There's mention of it, and then it caused a lab monitor to just have a minor heart attack. All right. Joins. See, normally this is like lecture 3 of SQL for me, so you guys are getting the abridged version. I'm just going to cover it in very basic concepts. Joins are used to retrieve data from multiple related tables. Okay? So, I've got a table called types. All right, in this thing I've got an ID and a name. Okay? And we got ID 1, 2, 3, 4. And we got open, closed, on hold, and
Standby.
on hold is the same thing. Not fixed. Okay? So we got a table called types. Now we got another table called calls. Okay, again, this has an ID, and it's going to have a type ID, and I don't know, I'm going to call, let's say, phone. Okay, and again in here I've got 1, 2, 3, 4, 5, 1 million. And the type ID here, this one's a type 1, that's a type 2, and that's a type 1, that's a type 3, that's a type 1. And the phone number is 555, whatever. The phone number is actually not that important for this example, so it's like this, okay? So we got two sets of tables that are related to each other. How are they related? Anybody want to take a shout out?
Type ID. Yeah.
The type ID. This is the ID of a type that we find in the types table. That's how you read that. Just to reiterate the naming conventions. Right? This is the ID of a type that you can find in the types table. All right. So let's just say I want to retrieve a report that has the call ID, the phone number, but I also want the type. Now, how many of you have had a pointy-haired boss type manager? By that I mean a manager that's less useful than a bowling ball. Okay, anybody who's worked has had one of these, honestly. You know, not everybody has a nuclear engineer as a boss. My boss scares me. He decided to do software because he didn't want to go in the dark. Oh, his exact words. So he understands these concepts, but imagine if I returned a piece of data to the average boss where I said I want the call ID and the type, but all I returned is 22555 31555, and then I'm pointing how your boss says, what the hell is call type 1? Really? Type 1 is type 1, dude. Go look it up. Yeah, that's going to go over well. How long do you think you'll be employed after that statement? Right? So at this point, you want to use something called a join. In other words, you want to retrieve the ID, the phone number, and the name from another table. And you use a join to retrieve those pieces of information that are related, but that come from a different source. Now, it says there's 3 common types of joins, but you see 4 listed. There's the inner join, which means they both must exist. There's left joins and right joins. I'll cover left and right joins later. Not tonight, like later. And then there's the full join, which is this magical thing that is so useless that almost nobody uses it. Full joins are for creating matrices. Anybody here remember math and the word matrix in math? Yes. Oh, you remember matrices. Okay, I thought you had a question. No, you remember the concept of, well, okay, full joins are for matrices, essentially. You want to create a matrix. That's what its purpose is. All right, inner joins. Venn diagram, folks. You know, when I was in college, we actually had a math class, and we spent a week and a half on Venn diagrams in math.
Week and a half.
The college program I went through went through a school of business. It was back then computer programming was part of the school of business. Now, they didn't have technology schools. So we learned business math. What math do you need to be able to do business? Multiplication, addition, subtraction, division, percentages, modulus, and Venn diagrams, apparently. Because, you know, the only way to explain to a boss what's happening is to draw a picture. No, really, that's literally what our prof said. This is why, so you can explain to your bosses what's going on with pictures. Welcome to math. Okay, the most common type of join is an inner join. The magic thing about most databases is you can choose to drop the word inner. If you use just the keyword join, it automatically assumes inner. So the shorthand of an inner join is just straight up the word join. What it does is it returns records that match in both tables. So in this case, let's say I did a join from types and calls across the foreign key primary key. And I said, give me everything up to here. So pretend there's nothing down here anymore. right? What I would return is I get 1 open, whatever, 555. I get 2 closed, 555. 3 open, 555. 4 on hold, 555, and then 5 open, 555. Because that's the way these tables are set up. These are the pieces of data they have in common. As you noticed, type 4 doesn't show up in this table. Therefore, it doesn't exist in both tables.
What did you just output there?
I did a select ID and phone, join the types. I'll be typing it up on the screen in a minute. Join the types and give me the name from types.
Okay.
That's what that is. So what's happening is I'm joining on the type ID, which is in the types, which matches to the primary key of the types table, and it only goes a full join, like an inner join. We'll say connect only where this value also exists in this table. So if there's any values in this table, or at least in the selection criteria, from here that doesn't exist here, these will not be returned. And if there so happens to be values in here that don't exist in here for whatever reason, let's say you happen to have one where you don't know what the type is, so the type is null, right?
That's not good.
It's not going to get returned either because it doesn't exist in this table. That's what an inner join does. It says it grabs data from A, data from B, but only where there's a complete match between the two on the selection criteria. That's a join. It hurts. Okay. I'm skipping the last slide. Some additional notes about joins. Things you need to know, and then I'm going to actually do a quick example up on the screen. What time is it?
8.
Oh, still got an hour.
Oh shit.
I'm kidding. I'll be done in about less than half an hour. I think we're all burnt out by now. Me too. I haven't taught a 4-hour class in about 6 years. Okay. Some additional notes about joins. You don't have to join from primary keys to foreign keys. You can join from any field to any other field. But if the data doesn't match, it's useless. A common use for this is, let's just say you have a customer table and you have a contacts table where people are just sending you messages from your website. And you want to know all the customers and the comments they supplied. And of course, you don't have a customer ID on here because this is just a form that accepts any crap. You could join across email addresses. Not a primary key or a foreign key, but they have commonality between the two, email. But usually, 90% of the time, 95% of the time, you're going to join from primary key to foreign key. Why? Because what's the point of having a primary key and a foreign key if you're not going to use them? You can join as many tables as you want. I happen to have an SQL statement that I use on a regular basis that joins about 14 tables. Why? Because that's just how complicated that piece of data is. There's no limit. Now, there's always a price. You know, you go have Whopper Wednesday, and you have as many Whoppers as you want, but you know what the price tomorrow is going to be. Right? And if you have a Whopper recently, you know what it does to you. It's almost as bad as Taco Bell. There's a price. And the price is, in database terms, is processing time and overhead. The bigger the join, the more you have, the more memory it takes, the longer it takes to process because it's got to collate so much more information. Order of the table is important. So when you're creating your join syntax, and you've got, this really sucks that they gave you that such a small whiteboard area between the screens. At least if I could turn off one of these projectors. So I've got table users, and I've got table types, and then I've got a table called calls. Okay? Depending on how you set up your rules and how the joins are set up, if calls depends on users and types depends on calls, and if you were to go grab data from users and types and you had calls down here, the query may not work right because it cares about the order from top to bottom. Select from table A, join table B, join table C. It will literally process A, B, C. So therefore, if C is depending on something that A has and B is not included for the ride, the connection is not going to happen. So if you go A, C, B, it's not going to work because the database structure says A, B, C. The order of the join in the tables in the join is important. This is just notes you need to know, like off the top of your head. Aliases are handy for shortening table names if you happen to have atrociously long table names. Also, you either have alias your fields if you have duplicate field names. For example, if you had two tables, one called customer type and you have ID and name, and then the customer field has ID and name, you tend to use what they call a table prefix. In other words, select A.ID, B.name from A join B. Why? Because database servers aren't that smart. If you just say select ID, name, it's going to say what name and ID do you want? I don't know which one you want, therefore tell me. These are the error messages you're going to see. So I'm going to pull up my SQL editor, and I'm going to type a little bit. Do a 2-second demo on joins. Okay, dokie. Close. And I want to go like this. Transition. Okay. This. Oh, no, over there. Come on, do it. There we go. Now I'm going to turn myself around so I can actually see what's on the screen. Yeah?
Could you just show us how to type distinct as well? You just went over it. I just want to see it.
Yeah, I can do that. I'm just pulling up some stuff here. Believe it or not, I don't actually see what's on the screen on this screen. You know what I'm going to do? I'm going to turn my laptop around because I'm not using that I have audio again. Okay, I guess I'll explain really quick again because I cut out my audio and I didn't plug my camera. Brains, I got none. Some days. You know, it's been an hour too long on a lecture when I do something that stupid. Okay. As the short form, that for those that are going to be watching this without the audio for the 5 minutes I was typing, you select your fields from a table, you join another table on a point of commonality. So you pick from one table, you join the second table, and you tell it how it's joined up in the middle. That's how it works. Okay, now. And by the way, this database was created a couple of years ago when I had a student complain that the databases they were working with didn't feel real. That they ran a query and he would come back in, you know, 10th of a second. I said, really? Well then, let's have some fun. So I have 47,000 orders, right? Let's see how long this takes to run. I love it, the counter going in the corner. No pressure. No, my hard drive actually blipped.
How many lines is this?
I don't know, I don't remember. We're going to find out in a minute.
What does that mean that it blipped?
Oh, my hard drive's so fast it normally doesn't. My hard drive like never flickers and it's actually starting to flicker. It's starting to swap. Oh, there it goes. 114,000 rows of data. Right? 24 seconds. It's a big data set. So as you can see, you can have as many joins as you want. You just keep joining. But I could not join order lines unless orders was already joined in above it. But I got to be careful when I say that, because some database servers don't care about the order and some do. So as a rule of thumb, I usually teach it that the database server is going to care about the order of the joins because some of them do and some of them don't. Therefore, you must get in the habit of being careful. That's how you do a join. That got recorded, and I will literally just as soon as I hit stop recording on this, I will go and grab this, copy paste it onto Blackboard for you guys so you have an example of a join. And I got to talk to Kamari. I got to send out some emails. Probably not going to happen tonight, but it'll probably happen in the morning to them, so that they have the naming conventions in place, because right now we've been just scrambling and trying to figure out what to do with you guys. For the naming conventions and how to handle what's left of the labs and what they're going to do with the assignment. But I'm going to post this so that and I'm going to make sure you guys have this database. The one I just pulled out of this is the one I use for my labs, for all my labs, is this database.
We already got.
You have ThinkCube?
We should have.
If you have ThinkCube, then you should be able to copy paste this in the SQL window for ThinkCube and run it. In theory. Now I'm going to hit the stop recording button.